at all my ideas, because these are the quotes of the most important people of today's, that they also stress that fact that creativity should be more developed in schools and more present in the STEM subjects. So it's according to Sir Ken Robinson, creativity is as important as literacy and mathematics and any other subject, and it should be treated the same. All kids are born genius, but they are crushed by society. Michio Kaku, famous physicist, also stressed fact that the future jobs that will be developed after this post-digital era will be based on creativity. Donald Knuth, computer scientist, also known as the father of algorithm, also highlight creativity in the process of writing codes and computer programs. And Steve Jobs also said that only science and technology married with humanities and art will give us results that we will be happy for. So three of them are the scientists in the field of STEM, computer scientists and physicists. Steve Jobs, only the Ken Robinson is not in the STEM field, but those three are in the STEM of the field. So why not follow that recommendation and do something about creativity? For example, this is one lesson that I got idea at the Kadme conference, where I saw a Hungarian dance representing algorithms, and I applied that in my classroom. We presented in one conference dedicated to education, and we attract, me and my students attract a huge attention. We were in the national newspapers, so this is one way to introduce math and coding to students through dancing, or maybe writing some math poetry. This is the latest, my latest lesson, workshop that won a national contest organized by Center for Science Promotion, a workshop that promotes mathematics. So it connects math and poetry, and believe me, you really need to be proficient in math to write a math poetry. So it's not a joke, and it's really hard to write math poetry. So, but also a good way to get students interested in mathematics. So by doing completely different activities. But one of my favorite way to convey mathematical concept and way that also include creativity is origami. Origami and mathematics are very very connected, and or maybe many people would consider origami as an art, but it's also a very serious mathematical discipline. It started in 1989 when Fujita Hattori established origami axioms, and since then many theorems, many mathematical problems got solution thanks to the origami. The most famous origamis in the world, Professor Robert Lang, who is physicist by his education, said that origami is so powerful that one day it will save human lives. It already do that because, for example, that in the car, the pillows that go out when there is an accident is folded by the origami rules. One of the most origami folds that end up in the space is Miura Ori fold. Space areas are folded by this on this folding, following those rules. So it's a really powerful mathematical and scientific tool, and also had this concept of aesthetics. So it's really like something that combine science and art, genuine. So this is one of the workshops that my students prepared for other students in the Center for Science Promotion. We were invited. School is where I work is situated in the northern part of Serbia, a very small town, village practically, and we don't have many opportunities, but with this kind of lesson we got noticed, and they invited us to give a workshop in the Belgradian Center for Science Promotion. So you can see students explaining to the other people and visitors during the session that how to assemble a dragon curve. Origami is mostly connected to the geometry. It's some kind of a natural connection that where origami can be applied in mathematical lessons. So, for example, this is one of the Platonic solids where we learned. We were assembling Platonic solids while learning about geometry, volume, surface, and things like that. Also, the other picture is acrylics. We were learning about trigonometry, so it can be applied in learning trigonometry and geometrical series. Origami and coding. This is a dragon curve folded from the paper, and another picture is dragon curve coded. The program is written, I'm not sure, maybe this is a C++ because it's already animated GIF, but we use that to learn some coding in Scratch. Actually, we wasn't learning coding, but some function like recursion was much easier to convey through the first we practice with origami, and then students grasp this concept of recursion, and then they were also discovering this concept in Scratch. So very high level concept was conveyed to the students with this way. This is one of the latest application of origami in the classroom. Many believe that origami is just for young students, but it's not. It's extremely hard to teach origami young students, but we made it with a flat origami, and we convey a two colors theorem to the students. So this is also one of the latest origami and augmented reality. And thank you for attention, because this is not where the story is stopping. We are researching this approach, and through many examples, it's really it can be really an approach for teaching mathematics. So, in case you have any question, thank you for attention.